Let's look at a few problems on page N of page 1135, particularly problems 72 through 78. All right, we're not going to solve all of these, but I want to just point a couple of things out because some of these are like trick questions. On number 73, 140 Newton force is required to move a 210 kilogram box up an inclined plane 20 meters. And the question is how much work. Remember, the formula for work is force times distance. We already have those two things. So what about this 210 kilogram box? Guess what? We don't even need that. All right, so we can skip that information. Yay! Now in 74, it says we have a 55 kilogram girl and she runs up a vertical height of 4 meters. So we have a distance. Do we have a force? Because to find work, we have to know the force times the distance. Well, remember, mass can be turned into weight, and then weight is a force. So we're going to take her mass times 9.81, and then we'll have newtons. Once we know that, we can multiply times 4, and we know the work. Now, 75 says how much work is done if she walks up the stairwell. Because here it says she runs. Okay, so the trick question, is it any different? Does it matter? Are you doing more work if you run than if you walk? No, that's actually exactly the same, all right? So it's just like a think question or a challenge your brain question. All right, now we do need to talk about which has greater kinetic energy. And a 35 gram bullet traveling at 300 meters per second, or a 100 kilogram person running at 7 meters per second. Now notice both of the velocities are already in meters per second. Yay! But we have a 35 gram bullet. So one of the first steps we're going to have to do is convert that into kilograms, which would be 0.035 kilograms. All right. And then you're going to solve both of these by plugging into kinetic energy equals 1/2 times the mass times the velocity squared. So you're going to solve this problem twice using the 300 and the 100 here. And then over here, whoops, I did that backwards. This would be the 7 seconds goes over here, right? So 49, we know the mass is 100, and then times 1/2. Over here, we're going to take the 0.35 as the mass, and we're going to use 300 as the velocity, and you're going to square that. So go ahead and solve both of those and see which one has the greater kinetic energy. And then I will just tell you, if you look on page 19 of your answer key, your score key, there is that solution manual, which instead of just giving you the answer, explains how on page 76 they solved it to get the correct answer. So then you can check your numbers against their numbers to see if you got the same number of joules. Okay, so both of these answers are going to come out in joules. All right, let's talk about number 77. This one's pretty straightforward. It says, what is the kinetic energy of a 2,000 gram truck? So we have the mass, and they give us a velocity traveling at 88 kilometers per hour, but notice that's not meters per second. So you're going to have to set that up and convert from kilometers to meters, and then convert hours in the denominator to minutes, and then minutes to seconds. So 60 and 60. You can leave the mass in kilograms, and then it's just a straightforward plugging into 1/2 mv squared. So I don't think I need to walk you all the way through that one. 78. Let's talk about 78. It says, what is the kinetic energy? Same formula. We have a 100 kilogram object It strikes the ground after 7.8 seconds after being dropped. So remember from earlier in the pace, we learned that the final velocity is 9.81 times the time. So we can take 9.81 times 7.8 seconds, and we will have 76.518 meters per second. So that's the information we're going to need now to plug into 1/2 mv squared. We use this formula so much that hopefully you have this one memorized by now, or you will soon. All right, and then your final answer should come out in joules once again, because this is energy. All right, we're going to stop this video, and I think we'll do one more for the bottom of page N.